Alexander Graham Bell's invention of the telephone in 1876 revolutionized communication. His device converted sound waves into electrical signals. These signals traveled over wires. This enabled real-time voice transmission over long distances. The telephone's impact was profound. It transformed personal and business communication. It broke down geographical barriers, fostering closer global connections. Early telephones were rudimentary. They had a simple transmitter and receiver. Users spoke loudly into the mouthpiece. The received sound was often faint, but the potential was undeniable. Inventors quickly refined Bell's invention, making it more practical and reliable, extending the reach of networks. Early lines were limited in length, requiring bulky, expensive copper wires. Engineers developed telephone exchanges. These acted as central hubs, connecting multiple lines, creating larger, efficient networks. Operators manually connected calls. Demand for automation grew. The desire for wireless communication emerged soon after the invention of the telephone. Early experiments with wireless telegraphy paved the way for radio. In 1901, Guglielmo Marconi transmitted the first wireless radio signals across the Atlantic. The invention of the transistor in 1947 was pivotal for mobile phones. Transistors made smaller portable devices possible. The first mobile phones in the 1970s were bulky and expensive. The 1980s transition to digital technology revolutionized mobile phones. The first digital cellular network in 1991 began the modern mobile era. The digital revolution of the late 20th century transformed mobile phones from simple communication devices into sophisticated pocket computers. The integration of microprocessors, memory chips, and software into mobile phones enabled a wide range of new features and applications. Text messaging, or SMS, short message service, emerged as a popular form of communication on mobile phones in the 1990s. The ability to send and receive short text messages offered a convenient and discreet alternative to voice calls. Text messaging quickly became a global phenomenon, connecting people across languages and cultures. The introduction of mobile internet access in the late 1990s marked a turning point in the evolution of mobile phones. Early mobile internet connections were slow and expensive, but they opened up a world of possibilities for accessing information, entertainment, and communication on the go. The development of faster data networks, such as 3G and 4G, made mobile internet access more ubiquitous and affordable, paving the way for the smartphone revolution. In the vast network of global telecommunication, each mobile phone is assigned a unique identifier known as a mobile number. This number serves as the phone's address, allowing it to connect with other devices within the network. Understanding the structure of mobile numbers provides insights into the intricate system that enables seamless communication across the globe. A mobile number typically consists of three main components: the country code, the national destination code, and the subscriber number. The country code identifies the country where the mobile phone is registered. The national destination code, also known as the area code, indicates the specific region or network within the country. Finally, the subscriber number is the unique identifier assigned to the individual mobile phone. The allocation of mobile numbers is carefully managed to ensure that each number remains unique. Telecommunication authorities in each country are responsible for assigning blocks of numbers to network operators. These operators then distribute the numbers to their subscribers. This hierarchical system ensures efficient allocation and prevents duplication of numbers. Section 5. Country codes delineating communication across borders. International communication relies on a system of country codes, which are numerical prefixes that identify the country of origin for a telephone call. These codes, assigned by the International Telecommunication Union, or ITU, play a crucial role in routing calls across international borders. Country codes typically consist of 1 to 3 digits. For example, the United States has the country code 1, while the United Kingdom uses 44. When making an international call, the caller first dials the international dialing prefix, which is a special code that indicates an international call is being made. The international dialing prefix varies depending on the country from which the call is being placed. After dialing the international dialing prefix, the caller then dials the country code followed by the national telephone number. The telecommunication network uses this information to route the call to the correct destination country and network. Section 6. The algorithm of connection, how calls find their way. Behind the seemingly simple act of making a phone call lies a complex and sophisticated network infrastructure governed by intricate algorithms. These algorithms ensure that calls are routed efficiently and reliably, connecting individuals across vast distances. When a call is initiated, the caller's phone sends a signal to the nearest cell tower. This signal contains the recipient's phone number, which is used to determine the call's destination. The cell tower then transmits this information to a mobile switching center, or MSC. The MSC is a central hub that manages connections within a cellular network. It uses the recipient's phone number to query a database called a home location register, or HLR. The HLR stores information about each subscriber on the network, including their current location. From voice calls to data, the expansion of mobile services. While voice calls were the primary function of early mobile phones, the capabilities of these devices have expanded dramatically over time. The advent of digital technology paved the way for the transmission of data over cellular networks, opening up a world of new possibilities for communication and information access. Text messaging, or SMS, emerged as one of the first widely adopted data services on mobile phones. The ability to send and receive short text messages provided a convenient and cost-effective alternative to voice calls, particularly for brief communications. Text messaging quickly gained popularity, becoming a ubiquitous form of communication worldwide. The introduction of mobile internet access marked a significant milestone in the evolution of mobile services. Early mobile internet connections were slow and expensive, but they allowed users to access websites, email, and other online services from their phones. The development of faster data networks, such as 3G and 4G, significantly enhanced the mobile internet experience, enabling activities like video streaming, online gaming, and social media browsing. Smartphones: the convergence of communication and computing. The smartphone revolution marked a paradigm shift in the evolution of mobile devices, blurring the lines between communication tools and personal computers. These pocket-sized powerhouses integrate the capabilities of traditional mobile phones with the processing power, storage capacity, and software functionality of computers, creating a new breed of devices that have become indispensable to modern life. Smartphones are characterized by their intuitive touchscreen interfaces, advanced operating systems, and vast app ecosystems. These devices allow users to make calls, send messages, browse the internet, play games, watch videos, listen to music, take photos, and much more, all from a single device. The app ecosystem is a defining feature of smartphones, providing access to a vast library of software applications that extend the functionality of these devices far beyond their basic capabilities. From productivity tools and social media platforms to entertainment apps and mobile games, there's an app for almost every need and interest. The future of communication, 5G and beyond. As technology continues to advance at an unprecedented pace, the future of communication promises even more exciting possibilities. The rollout of 5G networks is already underway, ushering in a new era of ultra-fast internet speeds, lower latency, and greater network capacity. 5G technology is expected to revolutionize various industries from healthcare and transportation to manufacturing and entertainment. The increased speed and responsiveness of 5G networks will enable real-time data transmission and analysis, paving the way for innovations such as remote surgery, autonomous vehicles, and smart cities. Beyond 5G, researchers are already exploring the potential of 6G and beyond, envisioning networks that are even faster, more intelligent, and more seamlessly integrated into our lives. These future networks could support technologies like holographic communication, immersive virtual reality experiences, and the Internet of Things, IoT, where everyday objects are connected to the internet. Conclusion: the unstoppable evolution of connectivity. From the rudimentary telephone to the sophisticated smartphones of today, the evolution of communication has been nothing short of remarkable. Each technological leap has brought us closer, breaking down barriers of distance and time. The journey from Alexander Graham Bell's groundbreaking invention to the era of 5G and beyond highlights the insatiable human desire to connect, share, and explore. The future of communication promises even greater integration, accessibility, and personalization. As technology continues to evolve at an unprecedented pace, We can anticipate a world where communication is more seamless, immersive, and intuitive than ever before. The story of communication is a testament to the power of human ingenuity and our unwavering pursuit of progress.